So we'll go ahead and we'll start the next topic, that is matrices and the matrix arithmetics. Okay. Okay. So there are two questions that I'd like to tell before moving to the next is actually the vector max norm is also called as an infinity norm. Okay. Vector this max norm is also called as a infinity norm. Okay. And this norm is specifically used for the regularization. Okay. This norm is specifically used for regularization, right? And hence, actually, as I told you, starting of this vector norm topic, that the norms of a vector are calculated for defining the vector space. I have not gone into detail about like different applications. Actually, the applications of the vector norm, it is on the regression analysis, right? This particular regression analysis is a special topic under machine learning. And to understand regression analysis is an entire topic of or one of the type of machine learning algorithms, right? So linear algebra, I told you, is a prerequisite or pre-topic for the machine learning. When you study the machine learning algorithms and there you apply various kinds of the regression analysis, there actually you will be going to use this norms, okay? And the max norm is specifically been used for the regression analysis, all right? Yes, Vasalvar. Okay, yes, Vasalvar is asking a repetitively question, that is why L0 norm is not defined. We have calculated the L0 norm. Okay. I didn't get your questions. We have defined it. Right? So we'll go to the next topic and we'll say that is matrix. So before moving ahead the matrices, I'd like to hear from you all how you define matrix, because matrix is a basic topic. You all have studied these topics in case of your HSCs, okay, or 12th, right? So all can tell me how you define a matrix, what the matrix is, and then we will define matrix in Python, right? So can you tell me what a matrix is according to you? All of you can enter your answer in the chat window. That is, what is a matrix, or how you define a matrix? What should a matrix contain? Or what a matrix is representing? Okay. So I can understand that many students have been known to the concept of matrices already. Okay. So all of you know what the matrix is, right? So matrix, in case of a Python or in case of programming, you would like to define a matrix is, matrix is a two-dimensional array, right? So vector we have defined in case of a Python or the programming language as a one-day array. Vector equals to a one-dimensional array, and a matrices which has n number of rows and m number of columns, it is going to be a two-dimensional array over here, right? So everybody has been clear to the definition of a matrices, or how we are going to define a matrix in a Python. In a Python, if you want to define a matrix of 3 rows and 2 columns, then what you will be actually going to do? You will be actually defining a 2D array with 3 rows and 2 columns, right? So we are going to explore this defining a matrix over here. So what I did is I calculated, I have defined A as a matrix which contains 2 rows. This is row number 1 and this is row number 2. And each of this row contains 3 columns, right? So I'd like to have one important note over here. You all have specified in a chart window the definition of a matrix, that is having n row and m number of columns. When I say a matrix has n columns and n rows, then it is explicitly expected that each of this row must have the m columns exactly same. That means if I say a matrix is of size, okay, when I say define a matrix of size 2 rows and 3 columns, right? So in that case, it will be mandatory to have each of this row containing 3 values corresponding to the 3 columns, right? So you can observe in this example that this is row number 1 and this is row number 2. So we have 2 rows and each of this column have 3 values. Each of this row have 3 values corresponding to 3 columns. This is column 1, column 2 and column 3. When we execute this, we will get the output of row 1 and row 2. In earlier, some students were asking like this. If I define the matrix B equals to, so whether it is correct, which are defined over here about B, whether it is correct, will I get the correct output? Okay. So many students have given a correct answer and they understood the concept of a matrix, actually defining a matrix. So what we were expecting here to have 2 rows. Okay. So we will go and check whether we have defined it correctly or not. We will explore one by one each of this parameter. Okay. So in case of a matrix definition, I specified that I want 2 number of rows and I want 2 number of columns. Okay. So here I have column row 1 and row 2. Okay. So I have row number 1, comma, row number 2. So this parameter is been satisfied. What about the second parameter? Okay. So we will have the second parameter, that is 2 number of columns. So now we will go and check here. So we have column 1 and column 2 is satisfied. And we'll go in the second row and we'll check. This is what? This is column 1, column 2, and this is what? One column is extra, which is not being supported. How many columns we want? We want 2 columns. And hence, if you try to execute this, what we'll have? It will provide a list. Okay? And we have already defined in the the very first lecture when we started a NumPy. I demonstrated you through an example what is the difference between a list and an array. Okay. However, if the parameters are so different, then it will not actually consider a numerical array. It will actually treat them as a separate list. Okay. And what I wanted is, I actually wanted a numerical matrix on which I can perform a various matrix arithmetics. But what compiler did is, as I supplied the wrong number of elements, it has implicitly converted this array into a list. Okay? So instead of taking this as a row 1 and row 2, due to not matching the number of elements, specified in the row 1, that is number of elements specified in row 1, and number of elements specified in the row 2, what compiler did is compiler has treated them as a separate list. Okay? And when you apply some mathematical operation on the list, it will not work exactly as an numerical operations that we have already defined. Okay? And we have seen one example. So what I need to do is I need to correct it. Right? Now I can have the two rows with exactly same number of columns. So row 1 with 2 columns and row 2 with the 2 columns. Now this is my correct definition of 2 by 2 matrix. And now I'm going to execute it. Okay? And here we have a correct result as in matrix. So hereafter, every student will remember this definition of a matrix. Whenever you specify a matrix of n number of rows, then ensure that 1, 2, 3 and so on, n number of rows are defined. When you specify there are m number of columns, then you ensure that each and every row will have same number of m number of elements. Okay. So we will move ahead and we have some matrix arithmetics. Okay. Under matrix arithmetics, we are actually going to apply various arithmetic operations on the two matrices. Okay. So first of all, we will see addition of a matrix. So to perform or to apply a matrix addition, I define first of all a matrix A, and I define a second matrix. I have a one question to all of you. As everybody has given me a very correct definition of a matrix, I have a question with you that if you would like to perform a matrix addition, that is say matrix A plus matrix B, or I can say here matrix C is equal to. If I want to perform this operation on matrix A and matrix B and assign it to C, now I'd like to know from all of you that according to you, what kind of a restriction is there to perform the addition of two matrices, or what is the rule we have to ensure whether this matrix A can be added with matrix B. Okay? What we need to ensure before performing addition of two matrices. Or in other words, I can say that when we say to apply an addition of operation on two matrices, what is that one condition that matrix A and matrix B must have in common? So exactly, so I'm very happy that I don't have to take much effort to convince you all that why the matrix of different dimension cannot be added, because every student has given a correct answer that when you want to perform an addition of two matrices, both the matrices must have the same dimensions. Okay. Like in earlier example, if you see what is the dimension of matrix B, it is 2 by 2. That means 2 rows and 2 columns. Say here the matrix A is having dimension 3 rows and 3 columns. Okay. Then to add it with matrix B, it must have the same dimension, that is 3 rows and 3 columns. Okay. Then the resultant matrix C will again have the same dimension, that is 3, 3. right? So we have this Pranay. Okay, who is this Pranay Bhattacharya? Pranay, I have already answered to this question, but still if you are repetitively putting it in the chat window, right now I have already started with the topic matrix arithmetic. So I will tell you to concentrate on this particular topic. After finishing this topic, I'll again take this question. Okay. However, I don't know where you was involved when I was answering this question, but I'll repeat this answer. But right now, just concentrate on what the matrix is and how the matrix operations are performed. So, and again, I'm trying to tell you to all the students that whenever we are studying some individual topic that is like say matrices, then you should concentrate on the matrices. Before starting of a matrix, I have closed the topic of a norms and we have taken all the queries which were there in the chat windows, right? Now we have started with the matrices and now we will understand the topic of a matrix very, very clearly so that whenever a matrix being used in a practical use examples, there you won't find any difficulty. If you are studying the matrix and you are thinking about the norms, and if you are thinking about the scaling, if you are thinking about the slicing, if you are thinking about the reshaping, then what will happen? You will not understand the matrix and you will not understand the earlier topic also. So I request you to concentrate on the topic which we are studying. Okay, we will take all the questions one by one. Okay. So right now we have started with arithmetics operation on the matrices. And the very first operation is the matrix addition. And I am actually stressing on this particular thing is that because students end up by doing different mistakes because they don't ensure that when you are performing or when you are applying arithmetics to the matrices, whether they satisfy certain criteria or not. Okay. So like say for example, performing an addition. Addition is performed element wise. Okay. Matrix, two matrices will be added element wise. It means that the element of a matrix A is added with the element of matrix B of the same position. Okay. Same position, I mean to say, if the matrix A element is at 0th row and 0th column, it's been added with the matrix B element of 0th row and 0th column, right? And for that only, you must have the matrix A and matrix B is of same size. Okay. So matrix A is of 3 by 3 and matrix B is of 3 by 3. You can perform an addition and you can have the resultant matrix is again of the same size. Right? So why I am telling this again and again? Because this will change further in case of a matrix multiplication. There are two types of matrix multiplication. Number one is element-wise matrix multiplication, and number two is the elementary row and column operation. Okay. So in that case, we have somewhat different rule on satisfying the dimension of a matrices. So in your linear algebra copy, you can specifically write over there that addition operation is an element-wise operation. Element-wise, it means that the element of a matrix A is being added with the respective position element of matrix B, right? So we'll go ahead and we'll see this concept for an example. So see here, we have defined a matrix A. So it is of size. Size is nothing but a dimension. Okay, size is actually nothing but the matrix dimension. That is 2 rows and 3 columns. So this is row 1 and this is row 2. Column 1, 2 and 3. I have displayed the value of A. Then I define second matrix. So second matrix again with the same size, right? So this matrix have 2 rows and 3 columns. So we have defined the 2 matrices of size 2 columns, 2 rows and 3 columns. So matrix A of size 2, 3 and matrix B of size 2, 3. So what is your first criteria of matrix addition? That 2 matrices must have the same size, which you have already satisfied. Okay. So whenever you apply matrix arithmetic, you have to ensure these criteria. So criteria number 1 is on the dimension of the matrices. So here I have written this particular statement like this. Okay. Matrix C is equals to matrix A plus matrix B. I have defined the matrix addition operation as an elementary wise operation which is going to add the respective position elements. So we can guess here what the matrix C will have values. This is element 1. The first element of matrix A will be added with respective row and column number element of matrix B. That means 1 plus 1. Similarly, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5 and 6 plus 6. Right? So we will execute it and we will have a result. Okay? This is what the first matrix A. This is what the second matrix B. And we have displayed third, that is resultant matrix. That is matrix C. Right? So in matrix C, you can see the addition of this respective position elements is being displayed. That is 1 plus 1, 2. 2 plus 2, 4. 3 plus 3, 6. 4 plus 4, 8. 5 plus 5, 10. And 6 plus 6, 12. And this is what we call an element-wise operation. Okay? I hope that it is clear to you all what element steady or element-wise operation is. Now let's see the matrix subtraction. Now matrix subtraction is the same kind of operation, which is an elementary operation, element-wise operation. So we again have the same matrices, matrix A of size 2, 3, matrix B of size 2, 3. Okay. And now we are going to subtract the matrix B from matrix A. And hence we have written A minus B and C. According to element-wise operation, matrix B is being subtracted from individual element. Right? So I hope from the addition of the matrices it is clear to you all that is how the subtraction is going to be performed. And you can try to answer me in the chat window what you will have in the matrix C. Okay. Now just listen here. Few students, like I mentioned earlier, I will mention few names here as Rajwal is there, Rajwal, and then Priyanka is there, then Raj. Okay. These are saying 0. 0 you will get in previous example, but not this one. See here, what is the value of matrix B? Actually, what we are going to do is, in elementary wise, is first position element of matrix A, and this is first position element of matrix B. So 1 minus 0.5, you will get 0.5. Second position element of matrix A and second position element of matrix B. that is 2 minus 0.5. Similarly, third position element of matrix A minus third position element of matrix B, that is 3 minus 0.5. Okay, this is for row 1. Similarly, it will be performed on row number 2. So row 2, first element of matrix 1 minus row number 2, first element of matrix B, that is 4 minus 0.5. Similarly, the second element of second row minus second element of second row from matrix B. Okay? This way it is going to be performed, and nowhere you will get answer 0. So for those students who have mentioned 0, correct yourself. Okay, and we'll execute this and we'll see the result. This is matrix A, this is matrix B, and this is what the matrix C in the result. Okay. So I think it is clear to you all how this addition and subtraction is performed. Okay. So all of you can see on the screen the correct answer is. And those who have said 0, they can try to understand that how the element is performed. Okay, so it is correct. So those who have mentioned answer, this one is always correct. Okay. But I don't know why few students have mentioned 0. I think they might have assumed the matrix B as with the same elements 1, 2, 3, 4, 5, 6. Okay, and that's why they got 0, right? But here we have changed the element of a matrix B. Matrix A is same as earlier, that is 1, 2, 3, 4, 5, 6. But the element of a matrix B we have changed, and hence we got the output like this. Right? So now we will go ahead and we'll see the important operation which we require many times is matrix multiplication. Okay? And actually it has been defined by a scientist that is we call as an Hadamard product. Okay? So we're going to see how it is performed and what is the difference between other matrix multiplication and this one, right? Say we have defined a matrix over here with the same dimension, 2 rows and 3 columns with the values 1, 2, 3, 4, 5, 6. Then we have defined a second matrix of exactly same size. Right? All of you please concentrate on this particular topic and then we will see what it means. Okay. So let's see here the matrix A has been defined with 2 rows and 3 columns. Matrix B is defined with again 2 rows and 3 columns, right? And have the values corresponding to the matrix A and B as in 1, 2, 3, 4, 5, 6. I have printed the matrix A first and then I have printed the matrix B, right? Now, very important operation, right? You all have to concentrate over here that what operator I have used. Because at the starting of this matrix arithmetic, I have specified here that there are 2 types of matrix multiplication. One is an element-wise matrix multiplication, and the second one is row-column-wise matrix multiplication, right? So we will one by one go and differentiate each one of it and see an example on each one of this type. Right now, here I have applied a single asterisk, that is a star operator. Right? It says that matrix C is my resultant matrix is equal to matrix A multiplied by matrix B. Right? Now you all will note down here that a single star multiplication, how this operator is going to multiply matrix A with matrix B. Right? I'll execute this. Now we'll have the output of first print statement. What is the first print statement? It is displaying the matrix A 1, 2, 3, 4, 5, 6. Then we'll have the output of second print statement. This one. Print matrix B with the same values, that is 1, 2, 3, 4, 5 and 6. After that, we applied the multiplication and we displayed the value of C. Now observe here, this is very, very important. Okay, and this is a matrix C. How the multiplication is performed over here? First element of matrix A is multiplied with the first element of the matrix B. So 1 multiplied by 1, we got in the result as 1. Similarly, second element of row 1 from matrix A is multiplied with second element from row 1 of matrix B. That is 2 multiplied by 2, we got here 4. Similarly, the third value we got is, what we got is third element of matrix row 1, element number 3 is multiplied with row 1, element 3 from matrix B. So 3 multiplied by 3, we got here 9. Right? Similarly, for the second row, 4 multiplied by 4 is 16. 5 multiplied by 5 is 25. And 6 multiplied by 6 is 36. Right? Now, I want an answer from you all is, so this single star operator or asterisk operator between two matrices defines which type of a matrix multiplication? It is an element-wise matrix multiplication. Okay, right? So we are going to perform an elementary operation, that is individual element is applied to this operator. Okay? Element 1 of matrix A is multiplied with element 1 of matrix B. Element 2 of matrix A is multiplied with element 2 of matrix B. Element 3 of matrix A multiplied with element 3 of matrix B, and so on. Right? So I hope it is clear to you all that, and this kind of product is also called as Hadamard product. Okay? Right? So this elementary form or element-wise matrix multiplication is also called as Hadamard product. Right? And then we will see first of all the types of elementary-wise operation, and then we will have the row column-wise matrix multiplication. Right? So I hope this is clear to you all, and there have been no doubts on this earlier addition, subtraction and multiplication. Similarly, we'll go ahead and we'll see matrix division. I'm again going to tell you over here that matrix division is again a elementary wise operation. That is, when I say matrix A divided by matrix B, I mean to say that the corresponding element of matrix A is being divided by the corresponding element of matrix B. Right? So we'll see through example. This is matrix A with 2 rows, 3 columns, and this is matrix B with 2 rows and 3 columns. Now, see here, what I applied is matrix C is equals to A divided by B. When I say an element-wise operation is performed for a division, how the division is going to happen is the first element of matrix A will be divided by the first element of matrix B. Similarly, the second element of matrix A will be divided by the second element of matrix B. And the third element of matrix A will be divided by the third element of matrix B. This is for row 1, and same will be performed for row 2. Right? So from row 2, the first element will be divided by the element from second row, the first element. Right? So if you divide the matrix A divided by matrix B, then what do you expect in C? C will have the values all 1, 1, 1, 1. Right? Execute it and we'll see the output. Right? And as it is a division operation, it has displayed the floating point values. Right? As whenever you involve the division operation, square root operation, then in that case, the default values will be the floating point values, right? So 1 divided by 1, we got 1.0. 2 divided by 2 got 1.0. 3 divided by 3 got 1.0. Okay. Similarly, 4 divided by 4 is 1.0. 5 divided by 5 1.0. And the last one, 6 divided by 6 is 1.0. I hope these 4 basic operations are clear to all of you. Okay. And the next topic we have is the matrix multiplication, where I mean to say that it is a matrix multiplication by using, number one is a dot product. Okay. So number one is by using a dot product. So if you recall the operation of a dot product, and then we are going to apply it. So this is for all the students, those who were asking me whether the dot product can be applied on the 2D array. Okay. So all of you now can see in the last lecture we applied the dot product on 1D array. So this is for all the students, those who were asking the question how dot product is applied to 2D array. Now a matrix we have defined, matrix is a 2D array, and we are going to apply a dot product on 2D array. Right, so we'll go ahead with this. There is a question from Ashish that mat A multiplied by mat B is wrong. What do you mean to say? I didn't get your question. Why you are saying it is wrong? Please mention your question in detail, right? So we'll go ahead with the matrix multiplication, as we have mentioned here about the dot product applying on the two matrices. You can say the dot product applying on the 2D array. Okay. So this is matrix A. What is the dimension of matrix A? Okay. What is the dimension of matrix A? It is 3 rows and 2 columns. Exactly. Very good. Correct. Okay. So matrix A has row 1, row 2, row 3. 3 rows and 2 columns. Similarly, now matrix B. What is the dimension of matrix B? Matrix B has a dimension 2 rows and 2 columns. Right? Okay, okay. Very good. Correct, correct. So now just see here. I have one question for all of you and answer to this question. Remember, we have defined a vector like this in the last lecture. Array with values say 1, 3. Okay. This is say vector 1, and another vector 2 is equal to say array with values say 3, 2, 1. Okay. And now I'm going to perform B3 is equals to say B1 dot B2. Now all of you have to tell me what will be the value assigned to B3. I'll give you 2-3 minutes over here, okay? And this is a very important topic. If you understand this concept, okay, if you understood this concept, then probably it will be very, very easy for you to understand the matrix that is a 2D dot product. Okay, the matrix 2D dot product you can very easily understand if you understand this concept, right? So I'll give you 2-3 minutes. Recall from the earlier lecture, recall from yesterday's lecture that how you calculated actually the dot product of the vectors, right? Okay. Rohit, you said 6, 6. Why you are saying 6, Rohit? Okay, answer is 10, and almost all students have defined it. Okay. So from Harsh, your question I will take. I'll first finish this topic. That means this dot product. I'll first finish it and then I'll take your topic. Okay? So assume here this is vector 1 and vector 2. After dot product, we will be getting an answer 10. How it is? Its corresponding position elements are multiplied 3 into 1 plus 2 into 2, 4 plus 3 into 1, 3. So 3 plus 4 plus 3, that is 10. And now same kind of operations we are going to apply on the dot product. Here there was a single vector, okay? Vector 1 and vector 2. So a single vector was considered for multiplication. Now you can assume here a 2D array is nothing but the collection of vectors, right? And how it is? This is vector 1, that is a row 1. This is vector number 2, that is row 2. Okay? And this is vector number 3, that is row 3. So each of this vector we are going to multiply with a vector from array B. Okay. So in case of row and column wise multiplication, we will define one. So what is the row for multiplying matrix A and matrix B by using a row column operation? Okay. If you want to say matrix C is equals to matrix A multiplied by matrix B. Okay. If we have the dimension of matrix A is say R1, comma C1, and for matrix 2, say you have a dimensions R2, comma C2. Okay. So if you have a matrix C is equals to matrix A multiplied by matrix B, and matrix A have a dimension row number of rows and number of columns denoted by R1 and C1, and matrix B have a operation that is number of rows and number of columns denoted by R2 and C2. Okay. So when you try to perform this kind of operation by using row column matrix multiplication, then what is the restriction on matrix A, which was like Hirsch has defined. Okay. So Hirsch has defined this as in order to perform matrix multiplication, you must have number of columns of the first matrix equals to the number of rows of the second matrix. Okay. So I should say it in a different way. That is how it is going to perform. First row, first column. First row, second column. Okay. So similarly, second row, first column, and second row, third column. Right? This way, how it will go. Okay. And hence, the definition what Hirsch has defined is very correct. That is, you must have the number of columns from the first matrix is equals to the number of rows from the second matrix. Because how elements will be multiplied? The first row and first column. So if we have the two columns here, then there must be two rows to multiply each of this column 1 or the row 1 with column 1. Okay. And hence, if this has been satisfied, then only the matrix A can be multiplied with the matrix B. Okay. Now, I would like to recall from C or C++ programming, if you will have done this kind of matrix multiplication, that is row column matrix multiplication in those programming languages, then you might have been asked to write a program for this. And while writing a program, you have to explicitly check this condition. Okay? If you don't check this constraint, then you will end up in fetching an error, right? But in case of a Python compiler will does this condition checking for us, right? So you will have, as a programmer, you will have to ensure that from your side you are satisfied this condition when you define a matrix. Okay. And in any case, by mistakenly, if you forget by checking this order and you end up defining a wrong matrices, then Python will check this constraint for you and it will throw a proper error message, right? So we will check that error message in the next class, and for now we will see how the dot product is being performed and what you will get in case of a matrix C. This we'll explore in the next lecture, and we'll have here first of all this. Okay. So first of all, matrix A is displayed with value 1, 2, 3, 4. Then matrix B is displayed with values 1, 2, 3, 4. Okay. So matrix A is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, and the matrix C. Now I'll say here it is first row and first column, that is 1 multiplied by 1 plus 2 multiplied by 3, that is 6 plus 1 is 7. Similarly, first row multiplied by second column, that is 1 multiplied by 2 plus 2 multiplied by 4, that is 2 plus 8, that is 10. Okay. So I'll go here and I can show you that if a matrix A has size R1, C1 and matrix B has size R2, C2, then what will be the size of matrix C, that is the resultant matrix? What will be the size of matrix C? Exactly correct. Okay, Yash has given a correct answer that matrix C will take the size R1, C2. This will be the size of matrix C, right? Okay, so hence the size R1, how many number of rows were there in matrix A? 3 rows. And how many number of columns were there in matrix B? 2. And hence the matrix C will have a value 3 rows and 2 columns. Okay. So how the second row has been defined? With second row first column multiplication, that is 3 multiplied by 1 plus 4 multiplied by 3, that is 12 plus 3 is 15. Second row multiplied by second column of a matrix, that is 3 into 2 6 plus 4 into 4 16. Okay, that is 22. Harsh, would you like to say this matrix multiplication of 1 to 3 and 3 to 1? Are you like pointing to this particular topic here for the vector 1 and vector 2? If you are pointing to this, yes, then it is not a matrix, dear. It's a vector of 1D array, right? I have given here an example to recall it. It's not related to this topic. It is to recall from. It is to recall. Okay. So this I have not defined for a matrix multiplication. I have just said you to recall this operation of a dot product from a vector, so that when you apply it on the matrix, it will work in the same manner. That is, this row 1 multiplied with column 1, that is 1 into 1 plus 3 into 2, that is 7. It comes here. Okay. So this way we have done with this matrix multiplication, and there is another operator to perform the same matrix multiplication, and there are some other matrix arithmetics that we are going to explore in the next class. Okay. So that's it for today's class, and you practice at home. I'll share this Python notebook file with you all, and after that we'll take some queries related to this topics, and then we'll see further topics in the next class. Thank you.